And I am live, and today is 2nd of July 2025, Wednesday. And yesterday I didn't stream because yesterday I there was a competition, Codeforces 1034, and in today's stream I will be analyzing the questions in that competition by reading the editorial. And yeah, I did three questions, and let's see how it goes. Let's just simply begin. My bad, I have to hide this thing. That is much better. Okay, I do not see the chat here, which is crazy. I have hacked that. I can stop this. I will be able to see the chat here. And I added this little icon here, which is good. Shit, I actually cannot see the chat here. That is crazy. Now, to Codeforces. Let me see, is my rating out? Current standings 3 out of 7. Is okay, it is still not out. I should have seen some number, big number here. That would have indicated my rating, but no. I got 3 correct. That is cool. This was my and this one was my first competition. I was able to solve only 2 questions out of 8. Shit. In rating not here. Okay. I guess I will see the rating in some time. I don't know when. Let's go and see. First one I did, and it was pretty easy. I just had to see what n is, and there were only 4 possibilities. Yeah, only 4 possibilities, which is this. I take and and take modulo with 4, which could be any one of these, either 0 or 1 or 2 or 3. And Alice had to choose something, and then Bob had to choose something in which the modulo were 3. With 4, modulo was 3. And we know one thing, that A modulo, let's say 4 plus, wait, A plus B modulo 4 equals A modulo 4 plus B modulo 4. So that is the concept I used. So if the remainder were 0, then Alice could choose this 0 number, and Bob would not have any of these numbers. So Alice would win. But if remainder were 1, then Alice could choose any one of these, and the total modulo would not go up to 3. If remainder were 2, if modulo were 2, then Alice, if Alice were to choose 1, the number with the remainder 1, then Bob could choose this number, and Bob would pass that round. But in the next one, Alice would choose this and she would win, or she could choose this at the first place, and then Bob would have no choice to choose. Like the modulo will not go up to 3. But if the modulo were 3, then no matter which number Alice chooses, Bob will have a counter number. If she chooses 1, then Bob can choose the number with modulo 2 to make it equal to 3. If she chooses 3, then Bob can choose the number with the modulo 0 to make it up to 4, and that was what I did. And let me also show you something. I just restarted my laptop, so my tmux is empty. Like there is no session, but I have created a shortcut command tmux set, and it sets stuff. Tmux ls now 4 sessions are running. I can do tmux attach to contest, and it opens in new room. That is cool. In the contest folder 1034, my solution is this. I'm just checking if the remainder is not equal to 3, then Alice wins, otherwise Bob wins. And that was the correct answer. And let's see what the editorial says about that. One concurrent viewer is crazy. I don't know why I am unable to see chat here. Sorry, live chat is currently unavailable. That is crazy. Highlight video. Let's see the editorial for this solution. Let's see. Step 1, Alice cannot lose unless there are no numbers remaining for her turn. Yes, in particular, this can only occur if n is even. Yes, if n is even, then Alice chooses one, Bob chooses one. Okay. So Bob's job is to pair all numbers into disjoint pairs a, b with a plus b modulo equal to 3. If he can do so, he wins by choosing the paired number to each of Alice's choice. Otherwise, Alice wins. Yeah, that is the same. But what is disjoint pairs? Disjoint. Disjoint. The connection between uh, set if they have no element in common. Okay, we are just choosing like disjoint pair. Okay, then that is cool. It doesn't really matter. Bob chooses, let's say, 0 or 4 because he won't affect the value of A modulo. Like, he's going very slowly on this thing. Okay, he is iterating, which is very suboptimal, and this one is cool. That is what I did. But if there is a remainder that is either 1, 2, or 3, then Alice wins. Otherwise, Bob, because you can do that with n because you have to find the thing with n minus 1 because you are going up till n minus 1, and here I do actually do n minus 1, so this works. That is cool. So we can move on to the next one because this is exactly what I did. Now for the next one, this is so looks pretty bad. Here is a set. Um, Tournament. Let's see. In this, you are given an array of integers a to a1 to an. A tournament is held with n players. Okay, so there are in total n players. Player I has strength ai, while more than k players remain. While more than k players remain, two remaining players are chosen at random. Then the chosen players with the lower strength is eliminated. If the chosen players have the same strength, well, one is eliminated at random. Given integers j and k, where j is greater than 1 and k is less than n, determine if there is any way for the player j to be one of the last k remaining players. Okay, so what this means is that in the end, we have in total n players and we are given an array from a1 to an, and we have to do some operations at random. We will choose two players, and which the player with lower strength is thrown out and the player with the higher strength wins, still remains, right? So then we will be given j and k, and j will be the index of a player, and we have to say after when k only k players remain, will is there a chance anyway possible in which that jth player would be one of those last remaining k players. And for that what I did was my algorithm was simple. This is n, this is j, and this is k. Yes, that is it. So what I did was, in the array, I can say that I will pair up every single element with the highest element, with the element whose value is the greatest, so that when that pairing happens, every element will get out except the highest element. And let's say, since we are the one doing the sort, doing the pairing up, I can take up, like in this case, 4 is the greatest element, and if I were to pair 4 with, and I is 2, so which is this element. So except for the jth element, which is 2 in this case, I will pair up 4, which is the greatest element, with every other number, and that will eliminate all of these other numbers. And no matter what, it doesn't matter on j, k, or anyone, the at the end I will have two numbers remaining, my jth number and the greatest number. And if k is equal to 2 or greater than 2, then jth element can be there in the last k remaining elements. But if it is equal to 1, then I have to see, is my is my jth number the greatest number? And in this case, I can only have one element at the end, and the element that I am looking for, jth element, is 5, which in this case happens to be the greatest. So I can pair up every other element with my jth element, which is 5, and all of them will be removed, and I will stay behind with 5, and that is yes. And now in the last case, I can have only one element remaining, and the one that I am looking for to remain at the end is 1. But in the best case, in like normal case, I can choose the greatest element, that is 6, and pair it up with every other element which is not j, and all of them will be thrown out of the array, and at the end I would have two elements, 1 and 6. But since k is 1, I have to do one more pairing to get the number down to 1, and when that happens, 1 will be thrown out and I will have 6 remaining. So there is no way possible in which 1 would be in the remaining k elements. And that is what I did in my code also. In my code here, I'm taking j, n, k, j, and maximum is initially equal to 0. Then I am taking in maximum, whichever number is maximum, and I think I don't even need this thing. Shit, I don't need this. Shit, shit, I don't need this memory usage. Fuck. Could have stopped this. Shit. Int le equal int le, and c, let's say, and c, and if okay, that doesn't matter. It is like fine, pretty fine. It was just I would have to do comparisons in every loop, and that would be bad. So yeah. So after finding the maximum and finding j, I have to see, is j the maximum? If j is maximum, then is k great greater than or equal to 1? And I think it is always greater than 1. K is always greater than equal to 1. So yeah, I don't even have to do this in this case. I can just see out. Yes. Else I have to see. Else, in else case, I will have the greatest element remaining and my jth element remaining. And this would only be a yes if and only if k is at least 2 or greater than 2. And you can test it, and okay, yes, that is because I changed the folder. Makes sense. I choose the folder. Yep. I can be shit. Mm, C P everything in this folder 2.0.34/ASP. And I think now we should be good. Yep, now we should be good. Hmm. Okay, B tournament.cpp because I changed the place in which it was there. So yeah, yeah, but the code is correct. That's cool. And in the tutorial, I suppose it has the same thing. Step one, if k greater than 1, then the answer is always yes. This is because player J might never get picked. Yeah. And when k is equal to 1, then we claim that answer is only yes if player J has maximum strength across all players. Indeed, consider the set of players with maximum strength. It is impossible for all of them to get eliminated because the last one of them can possibly lose a match. So at least one of these players will remain at the end of the game. If player J is not one of these players, they cannot be the last player remaining. If player J is not one of these, yeah, they cannot be the last player remaining. And the code CJK and go through, take the maximum, take in this, and then this. When either this or AJ equals maximum. Yeah, good. Mhm. And now prefix. This was also, I was able to do this one also, which is cool. System testing, 84%. Does system testing mean how much of the code has been tested? And if that is true, then I should see 100% here or nothing here. Wait, what? How much penalty did I get in my earlier competition? I got 38, which is, yeah, which is fine, which is fine, which is fine. 12 plus 26 is 38. Yes. Ah, yeah. And the third problem, prefix min and prefix max. You are given an array A of distinct integers, and in one operation, you may choose a non-empty prefix of A and replace it with the minimum value, or choose a non-empty suffix of A and replace it with the maximum value. Note that for Note that you may choose the entire array A. Okay, for each element AI, determine if there exists some subsequence of operations to transform A into AI. That is, make the array A consist of only one element, which is AI. Output your answer as binary string of length n, where ith character is 1. If there exists a sequence to transform A into AI otherwise, or 0 otherwise. Okay. In this case, we are given an array and we have two types of operations. In one, we can choose a prefix, which is like from the start, we can choose a prefix, and that whole prefix will be replaced with the smallest element. So if I were to choose these three, these three elements will be replaced by a single element, and which will be the minimum of these, which is in this case 1. So I would have 1 4 7 2. That is one operation, and I can do another operation in which I choose a postfix. Starting from the end, I choose a number of elements, and all of those elements will be replaced by one number which is the highest. So if I were to choose this postfix, this would be replaced by 7. So I would have 1 and 7 on the right. Now I have to go through all the elements and see is there a sequence with of choosing prefixes and postfixes which I can choose, which makes the current element, either this, be the only element remaining in the array. The general approach is this. Well, if the element is in the middle, I can say for every element, I will see what is the minimum element on its left and what is the maximum element on its right. So if I were checking for 3, the minimum element on the left is 1, and that is what I will get because I cannot go lower than 1. I will have to have 1 on the left, and on the right for 3, the maximum element is 7. So no matter what procedure I go through, I will always have, after going through all the numbers on the right, I will always have 7 on the right of 3. So it becomes 1, 3, and 7 at the end. And there is, in this case, no way that I can choose in which I get in which 3 could be the remaining element, because if I were to choose, let's say, first 2, I would 3 will be replaced by 1. If I were to choose first 3 as a prefix, all 3 numbers will be replaced by 1. And if I were to choose postfix 7 and 3, 3 will be replaced by 7. And if I were to postfix choose all the 3 numbers, then they will be replaced by 7. So for 3, answer is 0. Now for 7, the minimum number on the left is 1 and the maximum number on the right is 2. So 7 is above both the right and both the left. So to make 7 the greatest, I can just simply choose all the 3 numbers as a postfix, and the maximum among 1, 2, and 7 would be 7. And that is why the answer for here is 7. Now, in this case, for 2, the smallest element on the right is 1. And when it is 1, I can choose 1 and 2 as a postfix, and I will get 2 because 2 is greater than 1. So answer is 1. So what I have to do is I will go through the array while I am taking the input, and I will see at every element I will have another vector which will give me at ith position what is the smallest element to the left of this thing. So at the first position I would have 1, and on the second position I would still have 1, and on the third position I would still have 1, and fourth 1, fifth 1, and second 1, because for all of these positions 1 is the smallest element to their left. And then I will traverse from the right of this array, and for 2 there are, like, let me show you, 4 possibilities exist. Let's say this is the element that is in question, and wait, no, this looks horrible. Let's say this is the element that is in question, and several possibilities exist. The left one and the right one, both are bigger than, or both are smaller than it, and then one is smaller, the other is bigger, or in the opposite order. Left is higher, then medium, and then the smallest. And I could make this the remaining one. If I were, in this case, I could make this the remaining one by choosing all 3 elements as a prefix. So they will be replaced by this. So we are good in this. In this case, I could choose all 3 elements as a postfix, and all will be replaced by the middle one. So we are cool. In this case, however, this was the case which was with 3, and this is the case which was with 3. On the left we have a smaller number, and on the right we have a larger number, which is 7. And in this case, it is not possible to choose these in a way so that the middle one remains. But in this case, I could choose the first two, and they will be replaced by the last two, and they will be replaced by this one because it is higher. And then I will be with this one, this thing, and I can choose this as a prefix, and they will be replaced by this number because it is smaller. So this also works. So in my code, I just did that. Here I have a minimum index which tracks the minimum and a maximum, and maximum and minimum. Yep. Why am I using MXR? Yeah. And mnx is a array which has all the minimum elements, which tells at the ith position what is the minimum element to the left of this thing. And minimum starts at int max because I'm looking for the minimum thing. So then after taking in the input, I see is the current minimum or this current number, which one is minimum, and then I put this in the array which is telling me about the minimum elements. And after getting the input and getting the minimum array, I have my answer. And why am I creating another array? Because I will be traversing from the end and I want to print from the start. So that is why. So then I make this mx array, and no, not this mx array. Mx is just a variable which is telling me what is the maximum number to the right of the current number, and mn is the minimum number. And then I am checking for these three conditions and if any of them is true, I print I put 1 in the answer, otherwise I put a 0, and then later on I am printing the answer out. So that is simple, and let's see the tutorial if that is somewhere different. Array Joshi, how many did you do? I could not do G. Bro, please tell how to do G. I will be getting on to G, and I only did 3 questions, which is not much. I only did 3 questions, A, B, and C. I will be getting into G. And yeah, for now, let's read the editorial for C. If A has size 2, we can make either of its elements the last one. If A has size 2, we can make either of its element the last one. We can transform A into minimum of A1 and 2 by choosing prefix of the size 2, and we can transform AI into maximum by choosing prefix. Okay. If AI is prefix min, now we can transform A into AI. We can transform A into AI. Okay, we can do so by first choosing the prefix of length I. Now AI is the first element of AI of A. If A is of size 1, we are done. Otherwise, we can choose prefix. Okay, if AI is the prefix minimum. Okay. Otherwise, we can choose the suffix consisting of all the other elements after it. Otherwise, we can choose the suffix consisting of all of the other elements of all the other elements after it. Yeah, because since it is the minimum, so yeah, cool. Now our array is of size 2. We can transform into desired by identical reasoning. If AI is suffix max, we can transform AI into A into AI. I do not totally understand what they are trying to say. Is there some problem? Now suppose that AI is not a prefix mix or min or prefix max. Then let AP be the prefix min till ith element and AS be the maximum of the suffix from I till the M. Okay, with you till now. We claim that it is impossible to remove PS or AS without removing AI. Consider the first operation which removes at least one of AP, I or AS. Okay, either it is prefix minimum or maximum. And we have AI. AP is smaller, and yes, that is the case, which is this case, and in this case there is nothing remaining. If it is the smallest prefix min, prefix max, and what is this case? Is postfix max, and it is postfix max, or you would say prefix minimum. Mm, that does actually make sense. Yeah. So in this case, it is prefix minimum. In this case, it is prefix minimum. In this case, it is postfix maximum. In this case, it is prefix minimum and also postfix maximum. And in this case, it is neither prefix minimum nor postfix maximum. Yeah, that is also one way of looking at it. And I guess his code would be smaller than mine. He's running 3 loops. I am also running 3 loops. One for getting an input, then for doing my stuff, and then for our output answer. Yeah, that is cool. Now to the questions that I was unable to do. Let's see. Mm, YouTube chat is still not there, which is crazy due to some reason. I don't know why the chat is not there. And why does it say #1 fan? That is crazy. And shit, shit. Nah, cool. Binary string battle. I was unable to do this question on my own. And still, fun. Now would be the first time that I'm reading its editorial. And yeah, I had some ideas, but I was unable to do this. Alice and Bob are given a binary string S of length n and an integer k. Alice wins if she is able to transform all the characters of S into zeros. If Alice is unable to win in a finite number of moves, then Bob wins. Alice and Bob take turns when with Alice going first. On Alice's turn, she may choose any subsequence of length k in S, then set all characters in that subsequence to 0. On Bob's turn, she may choose any substring of length k in S, then set all the characters in that substring to 1. Note that Alice wins if the substring consists of zeros at any point during the game, including in between Alice's and Bob's turns. Determine who wins with optimal play. So the question is this. I am given a string of zeros and ones, which I can simply copy from here. Let's say this one. And we are also given a number k. And k is something. And Alice has the power that she can wait. Alice has the power. Alice has the power that she can choose any number, any k numbers, and turn them into zeros. But Bob has to choose a subsequence. Like that is all the k numbers that Bob chooses have to be adjacent. So this like this. But Alice can choose any k numbers wherever they are appearing. So my thought about this is, well, Alice has to convert these numbers, all of them, into zeros. So initially Alice goes first, and if the number of ones in the string is less than k, then Alice wins. It She can choose, yeah, she can even choose zeros which are already zeros in the case when there are less ones than k. So when k is larger than the number of ones, then Alice wins at her first chance. But otherwise, she would have to see. Let's say k minus the number of ones is something, and let's call it, writing is horrible. Let's call it x. Let's call it x. So what needs to happen is that when Bob chooses a substring on his chance after Alice, that substring must contain at least X amount of ones. That substring must contain at least X amount of ones, so that those ones which were to be converted by Alice into zeros, the amount of ones would not increase. Right? If the substring that Bob chooses, if that has at least X amount of ones, in that case, on her turn, Alice, she would then essentially what Bob is doing, he is from X is the total amount of zeros that he can convert to one, but the sub pattern already has X amount of ones. So essentially, Bob is only making X minus one amount of ones. And when Alice's chance comes again, then Alice has to convert these ones, and she can in total convert k ones into zeros, and these k could be divided into these extra ones that she has to convert back into zero, which were zero, and in this she is left with x amount of ones which she can spare from this move, and in that she can convert these originally left ones, which is just crazy. But if Bob does, let's say, makes more than this amount of zeros into ones, in that case, Alice would have to, the amount of spare zeros that she can convert ones into would be x minus 1. And x minus 1 spare operations would not be enough to convert x amount of ones into zeros. So she is messed up in that case. So my approach with this was to go with every subsequence of k and see how many ones can she convert into zero, so that she has at least x amount of ones in every subsequence. And I was just unable to figure out how to do that. Yeah, I had the theory, but I was unable to figure out how to do that. And the game would end in this: first Alice, then Bob, then Alice. On Alice's turn, game would be decided if Alice wins or not. Non-binary string battle. Solution. Step 1. Let C and T be the number of ones in S. Then clearly, if C and T is less than equal to K, Alice can win immediately. That is true. Then now let's reframe Bob's win condition. Mhm. Bob can win if and only if he can ensure that before each of Alice's turn there are at least k plus 1 ones in S. Yes, in other words, he has to ensure that after each of his turn, C and T is greater than K. Clearly, after each of Bob's turns, C and T is greater than equal to K, since the entire substring he chooses is all ones. So he only has to ensure that there is at least extra one other extra one in S apart from the substring that he is choosing. That makes sense. That makes sense. That does make sense. So when Bob chooses this substring, so from Alice's perspective, she has to convert these two into zeros, and yeah, she will just have to convert them to save Bob from choosing these two. And let's choose an example in which Alice was winning. Okay, in this Alice is winning. In this one, Alice is winning, and the value of k is equal to 4. So, to help with this substring, Alice is to make this substring safe for her, she will have to choose these two ones. So, she is now remaining with two ones. That is an amazing two. She is now remaining with two ones. And for this substring, well, she has to choose this one also because there cannot be any spare ones outside. So this one is gone. These two are gone. Now she is remaining with just one. And then for this substring, she has already chosen this one. She has already chosen this one. That is good. And now for this substring, she just has to choose with this one. Now all the substrings are cool. That is cool. So in the end, she just has to choose this, this, this one, and this one, all of these. And then she will be cool. Okay, so I think, okay, now how to implement this thing? Is CNT greater than K and N greater than equal to 2 power K. If CNT greater than K, okay, and N is greater than equal to 2K. Okay, then Bob can always win because he can always choose a subset because since C and T is greater than K, so Alice there will after Alice's turn there will be ones which are remaining, and Bob can always choose a substring that does not contain those ones, those remaining ones. That is cool. That is cool. Then Bob can always win. Indeed, in on each of Bob's turn, he can pick any existing one in S to be any existing one in S to be the extra one. Now he simply has to choose a substring which doesn't contain this extra one. Then there will be at least k plus 1 ones. The k from the substring he chooses and the extra one. If n greater than equal to k, yes, k into 2, then there must be at least k elements to either left or right of this one. So Bob can choose such a substring. For example, consider n equals 8 and k equals 4. Suppose before Bob's turn, this is this, then S is this, then Bob can choose any arbitrary 10s if 8. So, and k is 4, and before Bob's turn, this is what he gets. Let's say he chooses this one, and then he can choose these four elements to convert them, and these four will be converted into ones, and he would have one remaining here. or he could choose these four elements and they will be converted into ones, and he would have one extra spare one outside. Step 4, this motivates Alice is strategy as well. Suppose that n less than 2 into k. Alice would like to make sure that Bob is losing value from his moves. Right, in this case, value from his moves. Notice that every substring of length k includes the element sk. Notice that every substring of length k includes the element sk. So after Bob's first turn, we have that sk equal to 1. Sk, okay. Sk, if we are going to the kth index. Okay, okay, makes sense, makes sense. Now, a winning strategy for Alice is to leave sk equal to 1 until her last turn, and otherwise choose any k arbitrary ones to flip. This guarantees that after every round, CNT decreases because Alice flips k once, otherwise Bob flips at most k minus 1 zeros, since AK is already 1. Since CNT is non-negative, finite and decreasing, it must eventually reach 0. Shit. For example, consider n equals 8 and k equals 5. Suppose that before Alice's turn in this, n equals 8 and k equals 5 in this 1, 2, 3, 4, 5. This one, this one will always be in no matter what subsequence is chosen. Then we have that C and T equals 6. Alice wants to choose any 5 ones except S5, which is this one. So she can choose these 3 and these 2, and they will become equal to 0. And then next chance Bob chooses, he will convert some of them. Yeah. So she chooses this, and converts it. Okay, now the solution. I will write the solution on my own. Be crazy, and let's see, do we have the results? Solution 3 out of 7. Current standing, current standing, or I don't know where the result will come. Penalty is 60 and rating has not changed. Okay, I'll just do the question then. This one, binary string battle. No, no, no. This is what I was trying to do. 1034 and first I get n, then I get k, I guess. That is the, yeah, that is the zoom. And then a string. Yeah. So cn, n, k, and string s, cn, s. Ah, before even going forward, I can do a few things. If n, the amount of ones that I have, yep, uh, it will depend on that. If even before counting, yeah, I have to count the amount of ones. So ones initially 0, or new syntax that I learned today, ones 0, and for auto x in a, if x equal 1, then 1 plus 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 plus. Yes. After that, if ones less than equal to k, then cout or Alice. Else, if n greater than equal to 2 into k, then cout Bob. Else, okay, else now I have to see the elements that are common in the middle, and that would include, okay, the elements that are common. It means that if I have elements like this, these are all the n elements, and let's say k equals to 4. K equals 4. When k equals 4, this and this. So no matter what Bob chooses, he will always choose this element. And if that is the case, and if this thing is already a 1, if this thing, if Alice can manage to keep this a 1, then she wins. And if she cannot do that, then she loses. And what would this depend on? This would depend on how many other ones there are. So it would depend on this plus this, because this element is being repeated. And other than this, the maximum Bob can choose is the repeated element minus, like 4 minus the repeated element, which is only 1. So 3. Bob. So there are always going to be 3 ones outside. And Alice can choose these 3 ones and then a separate one somewhere else. That would be cool. But in which case would this not be possible? The first one, Bob is winning because this is greater. And in this case, Alice is winning. In this case, Bob is winning. In this case, Bob is winning, of course. In this case, Alice is winning because k equals once. And in this case, Alice should be winning and she is winning. Let's say k equals 4, k equals 5. And let's say initially I have 8 elements. 1, 3, 4, 5, 6, 7, 8, and k equals 5. In that case, if the lowest amount of elements that Bob can choose will be this, and it will be this. So no matter what, Bob will always choose these 2 elements, and not just 2. I don't even have to care. I have to suggest if this one is k or not. Yeah, if I can maintain this, if Alice can maintain this one to be a 1, then every time Bob will only be making k minus 1 elements into ones, and Alice would be making k elements into 1 into zeros. So that's cool. And eventually Alice will catch up and defeat Bob. So can she maintain it? Yes, she can maintain, and yeah, she should be able to maintain it in every case, I think. Else, what would be a case in which she is unable to maintain it? And this thing, oh, my bad. Okay, now it is correct. Yeah, she should be able to maintain it. What would be the case? She has to accept this, or they're enough. So this thing, n minus 1 k n minus 1 n minus 1 is the amount of these. They should be equal, n minus 1 should be greater than k, should be greater than k. Uh-huh. And it should be, it cannot be less than or even equal to it. If n minus 1 is equal to k, then also we are good. But if n minus 1 is less than k, which would mean n is equal to k, because like n cannot be that small. So, yeah, I guess this is pretty much it. This is seems cool, and I cannot submit. Shit. Submit code. Practice allowed only for finished and unfrozen contests. Okay, system testing. Testing is going on, 91% done. Okay, so I guess this code is come pretty much done. We can move on to the next one. This seems to me correct. This seems correct to me. Mm, uh, the chat is still not there. Some reason. MEX. This one was also funny. Not funny, but I was unable to do this. Define the MEX minimum excluded value of an array to be the smallest non-negative integer not present in the array. The smallest, this function takes in an array and returns the smallest non-negative integer that is not present in the array. So you are given an array of size a and a of size n, and for all k ranging from 0 to n, count the number of possible values of MEX after removing exactly k values from array. So given an array, I can sort the array, and then to make any given element the minimum element possible that is not in the array. Shit, what if there are gaps in the array? Yeah, and this one I was just unable to do. I had some ideas, but I was unable to do this. Let's see. Step 1, let mix be the original mix of A. Clearly, we cannot increase mix by removing. We cannot increase mix by removing elements. After removing elements, we can increase. Mm, we cannot increase mix by removing it. Shit. Shit. We cannot increase mix by removing element. Let's say there is a number that is mix, and that number is not in the array. Of course, it is not in the array, and that is by definition it is not in the array. Shit. That makes sense. How can we increase mix? To increase mix, I would have to insert that specific element which is already the max, and we are not doing that. For which value of k can we make mix equal to I? That makes fucking sense. So I think we are going to create an array. You must have I always less than n minus k. I is the value that we are going to iterate from 0 to max, and since max is of an array cannot be greater than its size, makes sense, cannot be greater than its size. Furthermore, we must have frequency I less than equal to k, frequency of I less than or equal to k, so that I can remove all the appearances of I in k. Since we have to remove all its instances of I in order to make it mix of A. Okay. Now, step 3. Now we claim that these are the only constraints. So first of all, this thing, we have to go from 0 till max, and second for which 0 can we make max equal to 1 for I. Okay. We must have I less than n minus 1. Why n minus 1? I less than n minus 1, n minus x, n minus k, to make it equal to some, because I will be removing k elements and I will be removing them from the end of the array, from the start. If I remove any element from the start, if I'm sorting it, then the thing will always become equal to 0, right? So I have to remove elements from the end, and after removing k elements, the length of the array becomes equal to n minus k, and I cannot be greater than the length. Makes sense. Now we claim that these are the only constraints. Indeed, suppose that I is this and I is this, and frequency of I is less than k. We want to choose n minus k elements to keep. Yes, since I less than max, every element smaller than I is in A. Yes, every element smaller than I is in A, and since I less than n minus k, we can choose first one instance of every element less than I. Since I is less than n minus k, we can choose an instance of every element less than I. One instance of every element that is less than I. Now the max of our chosen elements is 1. So we just need to choose the rest of the elements without affecting is I. So we just need to choose the rest of the elements without affecting the mix. We can just choose elements arbitrarily as long as we don't choose I. We can just choose elements arbitrarily as long as we don't choose I, since frequency of I is less than equal to k. We have enough spare elements to reach our n minus k quota without needing to choose I. Okay, that is making some sense, but I cannot completely understand this. Let's see. Let's maintain a set of elements which can be max A after removing k elements. This is actually not making a lot of sense to me. Let answer k be the number of possible values of A after removing k elements from it. Now let diff be the difference array of answers. So these things are fuck. Minimum fixed points. I didn't do that. Okay, here is what I'm going to do. Analysis. Shit, I am Not even able to complete the analysis. I only did 4 questions analysis, and these three. Okay, I guess I will do the analysis on my own, maybe later. But for now, I can, like, I actually want to do some questions of my level. Fair numbers I was unable to do, but yeah, I'll just do some questions now. That seems a bit overwhelming. So I will just do a few questions and system test 93% completed. Let's go. It has only been 1 hour. That is crazy. Move brackets. Okay. Question. You are given a bracket sequence S of length n, where n is even. You are given a bracket sequence S of length n, where n is even and divisible by 2. The string S consists of n by 2 opening brackets and n by 2 closing brackets. In one move, you can choose exactly one bracket and move it to the beginning of the string or to the end of the string. That is, you choose index I, remove ith character of the string and insert it before and after all the remaining before or after all the remaining characters of S. Your task is to find the minimum number of moves required to obtain a regular bracket sequence from S. It can be proved that the answer always exists under the given constraints. Recall what a regular bracket sequence is. This is a regular bracket sequence. If S is a regular bracket sequence, then this yeah. So this is cool, this is cool, this is cool, this is cool are regular. This is uncool. This is also uncool. This is also uncool. Mm-hmm. Mm-hmm. Minimum. So I guess something like a stack, a counter would work whenever it has to start with the opening bracket, and whenever I see a opening bracket, yeah, I will have a counter, and whenever I see a opening bracket, I will increase the counter by 1, but also I will check the counter after everything. And whenever I see a closing bracket, I will decrease the counter by 1, and after decreasing, I will see what is wrong with this thing. Closing bracket. Wait, if it is a closing bracket, I see. So it would mean something like this. And that would mean before this, I had a regular string, but this thing is messing it up. Okay. So what I can do is send this closing bracket to the end of the array. And that would mean I have to perform one operation. That is cool. That's cool. Uh, that is cool. Okay. So do this. No, this is not a competition. Let's go in CP. Yep, here. Yeah. CD 1000 and new. Uh, Boilerplate int n pn n and string s pn s int pnt initially equals 0. For output x n s, what I'll do is if x equals opening bracket, I simply have to do cnt plus plus else it is a closing bracket, Then I have to do if C and T equally, if C and T, if it is something, then C and T minus minus, else it means that C and T is equal to 0, and if C and T is equal to 0, if C and T is equal to 0, I have to increase the amount of operations that I have to do. Int OP initially 0 and OP plus plus, and yes, I'll send it to the end, and then I will move on to the next character. If it is an opening one, then I'm increase my count. If it is a closing one, and my count is still equal to 0, so yeah, that is good. I would increase the amount of operations again by 1. Yes. Mm, Makes sense. Minimum. What? So all I'm doing is I am sending closing brackets to the end. What if I send some opening brackets to the start? If I do that, that would also be amazing. Some opening brackets to the start. That is also one approach I could choose. And but would there be a difference in the two? Yeah. A mismatch would only occur, I guess the answer would still be the same. In this, the answer is 1. In this, the operation is 0. In this, I have to send this to the end. Answer becomes equal to 1. In this, I have 3 closing ones. So, yes, if I have an extra closing one, which does not have a subsequent opening bracket to before it, then does not matter. Either I send these 3 to the end, or I bring 3 opening brackets from somewhere to the right to the start. That would not matter. Yes. Yep. 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 Makes sense. So I have to bring 3 for this one, and let's say I send these 3 to the end, and then I would have this sequence followed by this. So yeah, 3 would be the answer. We out, OP, the new line. C, and that is correct. It is called C, move brackets. Documents, programming, competitive programming. C, move brackets. This one, let's see. I think it is correct. And these 3 summations are from the contest. That is cool. It is in queue. Okay. Running on test, and it is accepted. That is cool. 93%, 94%. Okay, what is going on? Johnny and ancient computers. Let's go with that. Brain dead devs. That is crazy. Johnny and Johnny has recently found an ancient broken computer. The machine has only one register. This is horrible. Now much better. Johnny has found recently found an ancient broken computer. The machine has only one register, which allows one to put in their one variable. Then in one operation you can shift its bit to the left or to the right by at most 3 positions. The right shift is forbidden if it cuts off some ones. Okay, so in fact the one operation you can multiply or divide your number by 2, 4, and 8, and division is only allowed if the number is divisible by the chosen divisor. So why are you telling that we should figure that out for ourselves. Formally, if the register contains a positive number x in one operation, it can be replaced by one of the following: x into 2 into 4 into 3 if it is divisible by this. Yeah. For example, if x equals 6 in one operation, it could be multiplied by these or divided by 2 and nothing else. In one operation, it can be replaced by 12, 24, 48 or 3. Value 6 isn't divisible by 4 or 8. If some value is divisible by 2, it means that 2 is not 1. It has to be divisible by 2. Okay. Yes, yes, yes. Now Johnny wonders how many operations he needs to perform if he puts A in the register and wants to get B at the end. Okay, so he can only change the factors by these amounts. Okay, so it would depend on the prime factors of the number. The number can be pretty big, A and B, and I am given A and B. Let's see, this should be easy. And 6, A, B, in A, B. Now, I want to find the factors of A and B. And if it is not possible, then just start with 0. Why the fuck is it is 14 in this case? Because that is how many factors of 2 I have to multiply the number by. Uh-huh. Mhm. I have to go through A and go through B and find the factors of A and B, the prime factors of A and B. How can I find the prime factors of A and B? Prime is a shit. I can find all the factors of A and B. No, I want to find prime factors, but I would be going from 1 to under root A, and then I would be going through every number between 1 and under root A to see, to see the prime factors. Uh-huh, uh-huh. Like, first of all, no, they do not have to be even. Both do not have to be even. All I can do with A is take A and shift it left of left or right. 1, 2, 3. And 1, 2, 3. 1, 2, 3. Okay. 1, 2, 3, 1, 2, 3, 1, 2, 3. And that would decide. So I would like to work with A in binary terms and how to work with how to get binary of a number in B++. Decimal number, binary 0, decimal number, enter decimal number, and take in the decimal number if it is 0 after 0, otherwise initialize a vector which will contain the binary digits. Temporary number equals decimal number, then temporary, while temporary number is greater than 0, binary push temporary remainder by 2 and temporary divided by 2. Reverse, reverse, so that the MSB the MSB is on the left and okay, I'll write that. Uh-huh. Okay, makes sense. And then I can look for a subsequence in B which contains A completely. But I can multiply, yeah, multiply any number of times. There is no limit. Mm, How to find the sequence of a vector in C++. Using recursion, there is no function, it seems. I can convert the vector into a string, a vector of convert a vector of char to a string in C++. String, my string, begin and end. Cool. So after this, vector char a b, a binary equals nothing, and in 6 temp a equals a, while temp a, if temp a remainder with 2, if no remainder with 2, then a binary dot pv. If there is no remainder, then push back. If there is no remainder, then push back a once. Yes, push back a one. Else ab dot pv 0. That is cool. Do the same with b, temp b equals b, 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 b. I have a and b, and I can reverse them both. ab dot reverse. How do I reverse? It was in this standard reverse. Okay, reverse. It should be there. Reverse all AB and reverse all BB. Okay, now they are reversed. Now to convert them into string. String AS starts with all AB and string BS with all BB, and AS dot find AB dot BS dot find AS. See how this. Let's see on plan. Yes, it keeps on running. Wow. Because I am not increasing the temporary value. Temp E divided by equal to 2. Uh, yeah, of course, wrong answer. Hmm, what's that? See out is new line and also bs one out of them. First is 10 and 5. This is the order. First I'm getting A and then I am getting B. Mm-hmm. I can divide, shit, I don't have to do all of this. I can divide A by B, divide A by B, and if the thing is a multiple of first setting off the conditions, I can only, let's say, the maximum, if there is an answer, then let's say B is greater than A. In that case, I can keep multiplying A by 2 if there is an answer, and if not, then there is not an answer. A divided by B should return a multiple of 2, 4, 8, a multiple of 2. And if B is greater, if B is smaller, then I have to reduce A by some amount. So if A greater than equal to B, or more like B greater than equal to A. So B is greater than equal to A, and then I have to say if B divided by A, remainder with 2, or not a remainder with 2, then I do have an answer. Else, wait, let me have would not possible equals true, and in this case, and P equals false. Else, if not A divided by B, remainder. Now I don't have to do that. I don't do. It has to be a multiple of 2. Uh, mm I can do this. Take the maximum in one number and minimum in another. Yeah. And mx equals max A comma B, and put it equal to A, and B equals minimum of A comma B, and A equals max. Then I don't need to do this. I know that E is maximum, and if A, there is no remainder, then A divided by B. So now I do this. A divided by B modulus 2. Then I do have an answer. I don't even need this. Else we have -1 with a new line. Obito, hey, what's your rating? My rating is going to be updated in a bit. 94% wisdom testing, 96%. Currently it is 4 to 1. Yo. And I have fan number 2 due to some reason that is crazy. Mm, if it is possible, then I have to see what the number is. And n is a divided by b. Now, if this number is a multiple of 8, then I will do 8 maximum times. If n, if not n remainder 8, that is, it is a multiple of 8, then I have to see how many times, how much is it a multiple of 8. How many times? Yeah, I can multiply the given number by 8. This, let's say after this, we just divide both the numbers by b, which is the smaller number, and then we get that, which is equal to a, which is equal to n, and n, we just have to see if n is a fact. If n is a multiple of 8, then I will take as much 8 as I can. Shit. Caps lock on. No, it is off. That is good. And OP equals 0. So if it is this, then OP plus equals 8 divided by n divided by k, and n equals remainder with k, with 8. Remainder 8. Yeah. Yep. If not n remainder 4, then OP plus equals n divided by 4, and n remainder equals 4. If not n remainder, it is going to be a multiple of 4. What if remainder is 0? Then it will be increased by 0. Yeah. N divided by 2, and n remainder equals 2. And again, see out OP with a new line. I said -1 for this one, that is crazy, and 0 for this. Okay, -1 for this fourth. If they are equal, then number of operations is 0. No. I can add it separately. If a equal b, then yeah, 0 in the new line. Also this, also that. Okay, wrong for the fourth last also. Let's see. In this case, e should be equal to This should be the value of B and this should be the value of A. And when I do 1100 6 111 39 39 403,776 403,776 divided by 1001, I get a good number, and that number should be the value of n, and which is a multiple of 2, that is, it is even. Now I take n divided by 8, this thing, not remainder but divided by 8, does it return 14? Uh, shit, in one operation when I am multiplying by 8, it is more like multiplying by 8 power something. Makes sense. So multiply by 8, multiply by 2. Yeah, shit. Yes. Makes sense. Makes fucking sense. Makes fucking sense. Yeah, keep multiplying by 8. I could keep dividing it by 8 and bring it down to 1. That would also be optimal. Why n, there is not a remainder while n with 8. What I have to do is OP plus first of all, and second, n divided by equals 8. Yep. Do the same thing with 4 and then with 2 till it becomes equal to 1. But I am dividing n. TLE TE. Time limit exceeded. But how did this get here? Overlapping. What about the submission testing? 97%. Okay. That is the only while loop that I am running, and I'm dividing the number also, changing the value of the number. Dividing a number by 8. N equals A divided by B because A is the larger number and B is the smaller number. Mhm. While remainder it. Hmm. Let me do something. See out N with a new line. And this is called A Johnny. CD 1000 and 1 out, see out or slash out. I only have one test case in which one number is 1001 and the other number is 30 big. Let's see. It keeps on saying makes sense. Makes sense. Shit. Yes. And this thing. Yeah. Yeah. Shit. Because zero is also multiple of these numbers. Wrong answer. That is better than time limit exceeded. Okay, now it is because of this. Wrong answer only for this one. Only for that one. Still wrong. Yeah. And 1 of slash out. One test case 1001 and this number 0. 0. 0 is crazy. So we have n 0. A should be the big number and okay, A is becoming equal to 0 due to some reason. A equals max and what does max do? Max takes in long numbers. 1. Okay, Max is messing around. C++ returning 0 in C++. The range max element. What do we get information on internet? Read one expected result. So instead of max, let me do if A is less than B. Equals A and B equals N and well what A equals B and B equals N. And I didn't do that multiply that plus thing because the numbers are very big and I do not want to mess around with them. Now it is correct. So Max was messing around, messing up. A John Johnny and client. See, 147 is very easy. Yep. Refresh. 99%. Shit. Wrong answer on test. Oh, shit. Expected -1 found 1 for second number. Maybe the number is too big. So that one is bigger experience. 32. Uh-huh. 32 is achievable. I just expected minus. Why would you expect -1? In this case, B is bigger, A is smaller. Okay, why did I output 1, by the way? Just curious. If I divide both the numbers by P, a smaller number, rather than that, and mn equals, I hope minimum function works, A comma B, and then how do you need to do that? That's fine. this. So after dividing both the numbers by the smaller number, which is this, I get a equals to 1 and b equals to 32. And to get to 32, I can multiply a by 8 and then by 4, which means two operations. Multiply 8 by, no, which means two op. Shit, this is the one we are talking about. So I guess for this, the answer that I outputted should be 2. It is 1. It is 1. It should be 2. It is 1. Yeah, the actual answer is 2. My answer is saying 1. There is a problem with C++. Shit, the number limits and stuff like that. Because my algorithm would say that this is not possible. Look, it would return -1 for this thing. Okay. For this, it should return -1. What the heck? It is not even too big. Maybe. Uh, those are double. Take remainder of a double by 2. Okay, that makes sense. That makes sense. If either one of them is odd, mm, if a not a remainder 2 and not b remainder 2, and this condition which I already had, that should work. Submit. But today just doesn't seem to be my day. I am from time to time forgetting that I am even streaming all of this. Wrong answer on test 1 is actually crazy. Wait, why? Oh, yes. So the mhm. Okay, the smaller number can be even. Yeah, the smaller number can be odd. Yes, the smaller number can be odd. First of all, I have to see that the smaller number is a factor of the bigger number. Yeah, not a remainder b. Mhm. Let's see the standings. Still at 99%. That is crazy. NQ. It is still in queue. Right, and I will be ending the stream shortly after just this question. And this thing come. Ah, fuck. I did achieve, by the way, today's target, which was it is running now. That is cool. Which was to do some analysis. I did some analysis of half the questions, and I have solved here one more question, and I'm getting stuck on the second question. Let me get this right. Third found -1, expected 2, and yeah, you should expect 2. This is returning -1. -1 is crazy, so the greater and the smaller. I think C out A line and C out B line, and I will run that and say that I have only one test case, and these are the numbers. So, and one of them remains, but the other one gets smaller. B becomes like something else completely. B becomes now we are B. Okay, that was the problem because I was doing this as integer. Uh, now we should be cool, I guess, after this. Okay, submit. 100%. And where do I see the thing on my ID? Maybe. Oh, yeah, my rating is still not updated. Contests. Friends standing. Okay. How much rating did I gain? Bruh. I guess it will be updated in some time. Wrong answer on test 2 again. That is crazy. For 14, expected -1 found 1. And is 14 visible? 1, 2. 14 is this. 12, 2. Not just 2. Has to be only a factor of 2. I guess this thing. I can remove this and addressing the bigger one. If not a remainder B, then we might have a solution. Else we have -1. And in this case, if while n6 n equals a divided by b, and while n while n and n remainder by 2. Not that there is a remainder. No remainder by 2. And pnt equals 0. What I have to do, pnt plus and n divided by equal to 2. Yes. At the end, n should be equal to 1 because after 2, 2 divided by 2 is 1. So if n equals 1, then we are cool. Else, yeah, the same thing. Now, if this is this, then the answer depends on count. So int op equals 0 and cn op plus equals cnt divided by 3. Uh, yeah, divided by 3. How many 3 I can get? For 4 it would be 2, and for 1 it would be just for 2 it would be 1. And then pnt remainder equal to 3, and then op plus equal cnt divided by 2. And pnt remainder equals 2 and op plus equals pnt. Out pnt. It says wrong answer. uh, it is outputting 0. Why? What is the value of count? Count. Count is amazing. Count is what it should be, and I think this is the count in the 14 case. Uh, last two, then yeah, and then third last. Yep, it is the count in the 14th case. So 43 divided by 40 is 1 3 13, and after 13 the remainder is 1, so multiply it by 2. Okay, yeah, the cmt divided by 3. Adding to op. cmt divided by 2 divided by 2, 1 divided by 2 is nothing, and if it is 2, 2 divided by 3 is 0, remainder, yes, yeah, so this should work. But this would not work because I am actually stupid. Wow. You know, I messed up if I am outputting something else also. A Johnny computer. Let's see now. Uh, okay. Do I have my rating updated? No. My rating is still not updated. Final standings. Virtual participation. Uh, Now it is running. It seems like it will work this time. Yep. New accepted. That is good. And for today, that will be the end of the stream. Wait a minute. For today, that will be the end of the stream. And I haven't streamed as much as I would like to today. I only streamed for 2 hours, but yeah, on days and off days. This, I guess, is off. Ah, bye. Today is, to repeat the date, today is 2nd of July 2020.